everyone. Thank you for joining us today. We are Semgrep, and my name is Eric. We're going to talk about context-aware AI and how it's affecting the landscape of security products and how it is improving your ability to scan your code for vulnerabilities. My name is Eric Buchanan. I'm the head of AI for Semgrep, and here I have with me Chushi Lee, who is the product marketing manager for this part of the product. And he's going to go over what we're seeing in terms of AI advancements and Semgrep's assistant product and how we are using the fast-growing field, the heavily invested field, to improve the products for our customers and users.
Awesome, thank you, Eric. So our goal, if you go to the next slide, just go cover the agenda. But at a high level, our goal for this webinar is not to talk too much about our product. It's really to communicate, what we're building, how we've built it, and what our philosophy is to continue building out things into the future, right? Because again, everything's moving so fast in the world of AI. It's kind of funny. I feel like an early stage, kind of a mantra in early stage venture capital is you invest in the people and the team. You're not investing in the product. You're investing in the founder. Obviously, that's not really true with vendors, right? You're evaluating vendors based on the features that they have today. But I actually think there's this kind of unique situation we're in right now where everything is moving so fast in the world of AI. I think it really is important as you pick a vendor, especially in enterprise B2B SaaS, where you're signing year or 2 year long contracts. It's important to know how the team is thinking about these things because, again, things will be very, very different in 1 month. And you want to make sure that you're partnering with an AppSec vendor that essentially has the team in place, but also the processes and the scaffolding internally to essentially, when there's a new version of a foundational model, squeeze all of that value out and give it back to you guys as customers through, security outcomes. So if that sounds pretty daunting, yeah, again, our goal of this webinar is not to talk too much about our product, but just to help you guys maybe sort of build an idea of how to think about this kind of thing. And maybe, the next time you're in a sales call, not necessarily with Semgrep, questions to ask and kind of areas to, kind of apply some pressure to really get the idea of how does this vendor think about AI? Does it align with how I think about AI? Do I feel confident that these guys are going to be able to continue innovating? And yeah, I've said it a couple times before, but just squeeze all of the value out of these models that are coming out every 3 months. Next slide, please. Cool. So I think before AI was the buzzword in AppSec, everything was about shifting left, right? That could be a good 1-sentence summary of the last 10 years or so. So moving security earlier in development, trying to catch issues before they become costly. Obviously, this concept is valid. The intention is very correct. In practice, it just wasn't feasible, right? Things were too noisy. They were overwhelming for developers. Developers would often ignore issues. Essentially, someone would have to take the brunt of the false positive burden. So whether that's security engineers painfully triaging every finding before they send off a Jira ticket or before they create a PR comment because they don't want their developers to have unpleasant experiences, they would have to shoulder the burden. Or you could just have some fully automated quote unquote shift left system where you just, blast developers with all of your findings, knowing that 50% or 60% or even 70% of them are not actually exploitable issues. So shift left kind of introduced as a concept very early on, and everyone can agree it's a useful concept. It's very intuitive, but it's the mechanism, how do we actually get shift left to happen? That's not really something that's been solved for. I actually, I think until this AI boom, which is why we're so excited about all the stuff we're building today at Semgrep. So this is just how we think about false positives at Semgrep. And essentially, if you just look at that graph to the right, the kind of core concept here is you don't actually start to capture the true transformational value of AppSec. And when I say transformational, I mean things that a CISO would really care about in terms of outcome. I think right now AppSec occupies a relatively small portion of the CISO's mental map. And that's just because AppSec is kind of a tool that's designed to just help you keep up, right? To help you, desperately try to stay with the rate of vulnerabilities that are entering your production code base. I think with AI and what Eric's going to really talk a lot about is how, yes, there are things about AI that are kind of scary to us as security people, right? Developers one-shotting entire apps or developers just, writing a lot of boilerplate with AI generated code. But at the same time, on the side of the security team, AI is a fantastic force multiplier. It helps us do a lot more with a lot less. And I think our thesis at Semgrep is really that like the benefits that AI is going to give to security teams far outweighs, the additional risk that your organization is going to incur through developers using AI, so long as you have the right approach and tools in place to actually capture the value of just how quickly AI is getting better at understanding and reasoning about code. So yeah, this chart pretty much just says, you don't really capture the true transformational value of an AppSec tool until you get the signal to noise ratio up to a certain point. And then you just, you'll see on the graph, the value just suddenly starts to shoot up. And so we don't know exactly where that is, right? But somewhere around the 70 to 90% range, like if you can get to the point where 70+% of the findings you're showing to developers, they are confident are real issues, that is generally enough to overcome all of these like cognitive biases and psychological barriers, right? Because you kind of avoid that boy who cried wolf situation where um, if you get the signal to noise ratio to this point, developers, when they get a security alert, currently their gut reaction might be, annoyance, like, oh, that's really annoying. But if you get to that 70%, 90% figure, if a developer gets a security alert, their first reaction might be, oh, this is like something I should care about. This probably means that the code that I just pushed, whether a PR or it's already in prod, the code that I pushed like introduces some material risk to my company that could be exploited. And I think what we find is that like, if you have good, like I don't want to make a generalizing statement here, but most developers really care about their craft, right? And the reason that security could be annoying is because see a question from Clifford. I will get to that after the slide. Um, I think most developers really, really care about their craft. And the thing about security tools is it slows them down. It doesn't give them any meaningful signal into the quality of their code. So I think when you get the signal to noise ratio up, developers start to view security findings in a way that's like, they actually care about it. Like they see a security finding, they care about the quality of their code. They don't want to be shipping things that introduce risk. So I think in some of our customers who have really, really gotten the SNR rate up have really seen a corresponding increase in the fix rate, as in developers are really starting to fix the vast majority of issues that are brought to them before the AppSec teams even have to look at the issues themselves.
The question from Clifford is, wouldn't signal to noise be a ratio, correct in context slash reported by the engine?
Yes,
Or,
absolutely. So we're about to get into that here, but yeah, you were 100% correct. So kind of to Clifford's point, right? If you could go to the next slide, Eric. We really see like two types of false positives at Semgrep. And this kind of really illustrates the reason why static analysis tools and code scanners have a really hard time. Just noise is an existential problem with AppSec tools, like Semgrep Community Edition included, Semgrep included. And it's because these static tools, right, like they may be very, very good at capturing like directly matching insecure code constructions with like well-defined patterns. So whether this happens transparently like Semgrep or CodeQL, where you can see all the custom rules and custom queries, or if it's something, excuse me, like Sneak, where it's more of a black box, regardless, underneath the surface, right, you have all of these deterministic static rules that are just looking for specific patterns in your code, specific insecure code constructions. And Semgrep has always been very, very good at minimizing these kinds of false positives, right? So the first kind of false positive is where the code construction that the rule is written to look for just doesn't function correctly, as in like the rule author's intent is not met by the matching behavior. Now this is more rare, and again, Semgrep is very, very good at minimizing these. So where's all the noise coming from these days? And the answer is in contextual false positives. So like Clifford said, you know, the analogy I like to use is it's kind of like a smoke detector. So imagine a smoke detector that goes off when you're cooking, right? The sensor did not malfunction. The sensor actually worked perfectly. It's just the context of what you're doing at that moment. You're cooking, there's not a fire. The smoke detector is still going to go off. And I think in the world of AppSec, that's a really good analogy for like the types of false positives we see. And I think like similar to a smoke detector, right? Like we're all kind of resigned to the fact that our smoke detectors are going to go off when we're cooking. We're all kind of resigned to the fact that there will be false positives in SAST because the alternative is just not having a smoke detector. So I think with AI, what we're able to do is really start to identify and surface, hey, out of all of these false positives that you correctly matched, like the rule correctly identified, a very comprehensive set of potentially exploitable findings, AI is really good at saying, hey, what subset of all of those findings are actually exploitable, given what I know about the context of your code, your environment, the secure defaults that your organization prefers, all of that good stuff. So these are things like, if you go to the next slide, Eric, these are some examples of just like contextual false positives, right? So like the taint data source is trusted. There's no way a static tool would ever know that out of the box, right? You can just go ahead and like load all of the examples. But yeah, like, you have an internal service, an internal data source that's trusted. How is a static analysis tool, or, like how is a security vendor selling you a static analysis tool, um, ever going to be able to understand all of these things out of the box? It's simply not possible. So these are the blind spots of static analysis tools. They never look at context. And, you know, something that I like to say is that like, most security vendors, what they're really trying to do is they're trying to build a code scanning engine that works okay for every type of environment, right? They have to write generalizable detections, generalizable rules that work okay with any code base, but not excellently for any one particular code base. And I think the benefit of Semgrep, even before AI, is just that Semgrep has always been able to overfit to your specific environment, because custom rules with Semgrep are very easy to write. Compared to other tools, I think writing custom detections with SemGrep is like a very, very agile and very, very scalable. If you go to the next slide, Eric, um, these are just more examples of like contextual false positives, right? But what one thing we've learned at SemGrep is that even though we have rule syntax that is pretty simple, so for example, writing rules in SemGrep, it doesn't require any domain specific language. If you're writing a detection for Python, like the Semgrep rule you're writing just looks like Python code. It looks like source code. But despite this, people still really don't have the time to write a lot of Semgrep custom rules. That's the one thing I would say one of our biggest learnings from a product perspective at Semgrep over the past, 2 or 3 years. And so luckily, because our rules, even if, a lot of AppSec teams don't have the time to write a bunch of custom rules, luckily we still get a lot of benefit from our rule syntax just looking like source code and being so understandable, because it means that LLMs also really understand SemGrep rules. You can ask an LLM, it can literally just be a foundational model. Like you go into ChatGPT, go into Claude, ask it to write a SemGrep rule for some basic detection, and it'll be able to do it. So that's the kind of, I think, benefit we have going into this space, or one of the benefits we have going into this space that's really exciting, is that we already have an engine that is really, really easy for AI to, understand the inputs and outputs of, and, in the case of like our MCP server and whatnot, like actually call as a tool. Next slide, please. So here, I'm going to talk a little bit just about, go one more slide. So what we've built. So given that previous slide, right, it's clear the thing that we need to do is we need to figure out how to identify these contextual false positives. And so at Semgrep, what we've really built is a system that helps LLMs identify and reason about these contextual false positives in a way that's very effective and, more importantly, like very reliable. So what you see on this slide is just, an example of all the inputs we have. We've built these prompting and retrieval systems that help any large language model reason about your code. And the way I like to explain it to customers is like, we help AI reason about your code like a security engineer, but also like a security engineer who also has the knowledge of one of your developers who's been with the org for years. So a security engineer that actually understands the nuances of this specific repo or this specific project, or like what this code is doing, um, what part of the application this code touches. Is it related to payments? Is it related to authentication? And so what we really tried to build at Semgrep is just again, these retrieval systems and these prompt chains that take all of these inputs that you see on this slide and give any AI the ability to access these inputs when they need to make the best security decisions possible in a very reliable way. And so I think like when it comes to our AI philosophy, it should be very clear that it's like, this is not us saying, hey, our AI is very good at identifying false positives. What we've built is a system that allows any AI to make security decisions better. And so what that means, I think, is, when new models come out, it doesn't really matter how capable the model is. The model will always be better using through Semgrep than it is on its own when it comes to doing security related work. And the cool thing about, as these models get better is what we find at Semgrep is like the scope of work that the scope of work that we're able to say Semgrep can confidently do with AI is increasing. And so I think one thing that's really hard for me as a marketer is just, when you go to all of these like events, like whether it's like RSA or whatever, it kind of seems like a lot of the vendors are saying the same thing. Um, and I think even when it comes to like the front end and how the products look, anyone can build a system that just takes a finding, hands it off to ChatGPT, and they have a simple prompt chain that just asks, hey, is this a false positive? Or like, hey, can you generate a fix for this finding for me? And ChatGPT will give them an answer. And so it's like, it's been really challenging for me as a marketer to like, how do I communicate to people that what's happening behind the scenes, all of the context that we're passing the AI, that's what makes the outcomes actually different for Semgrep versus another security vendor that also has autofix or also has false positive detection. Like, why are the outcomes and the results more accurate with Semgrep? And so this slide is that. It doesn't look great on a landing page. It's a little bit dense, but if you're at this webinar, you can read through this, and I think you can start to build an understanding of like why our systems are accurate and more accurate compared to others. Next slide, please. So just to zoom out a little bit and get less Semgrep focused, I think if we're talking about the market as a whole of AppSec and AI, so this is a framework that Leonis Capital put together just for understanding how AI products fit into a landscape of like competition and like the kind of moats that they have. So it's a simple and effective way to categorize AI applications across 2 dimensions, right? On the x-axis, you see if it's a horizontal focus versus a vertical focus. So like a vertical focus would be like security or like legal review for like like contract redlining in like law. And then a really horizontal application is just like text summarization or like a chatbot, right? And so the more you go to the right, the more kind of defensible an AI application is, in the sense that like the new version of ChatGPT could definitely render, like, for example, some of those AI sales applications where it automatically does outreach for you, those could be quickly rendered obsolete by like a foundational model, getting a lot better. But the more to the right you go, the more defensible your product is, because these foundational models don't have this highly specialized, verticalized knowledge and scaffolding built around it. And then from the top to the bottom, you just get how technically complex is this thing, right? So the way I think about it is that most AppSec vendors right now in their use of AI are kind of in the bottom right zone. They're in zone 2, where like they have some industry specific context that they're passing to the AI. It's obviously vertically focused, right? So it's retrieval and generation that's focused around a security use case. And there are some basic like workflow builders. And I think at Semgrep, what we're really trying to do, and I think we're already on the way of moving up from zone 2 to zone 4 on the top right. But long term, we want to be fully in that top right category, right? Where we've built all of the scaffolding around the AI that really makes it so it doesn't matter how good ChatGPT gets, it doesn't matter how good Anthropic gets. That kind of like all of those edge cases when it comes to identifying false positives, we're not just right 60% of the time, we're right 90+% of the time. That's really the zone that we want to be in. And I think we're already like making pretty good progress in terms of that. Next slide, please. So actually here, I'm just going to hand it off to Eric. So he's the technical person. He can explain a lot more. 2 slides ago, when I was talking about all of the inputs, Eric can really explain why all these things are necessary, and just he can get more into the details of like, what's our philosophy around building this thing? Why do we think it's defensible in the market? And maybe you learn a little bit about how we're thinking about things at Semgrep, how we're doing things at Semgrep, and it'll be a good framework for you to just ask other vendors or anyone you're having a conversation really with about a SaaS tool, how they're thinking about AI. So I'll hand it off to Eric.
Thanks, Jushi. Thanks again for joining us, folks. So what are we doing with this AI within Semgrep? Semgrep Pro Engine creates findings, which is what we call things that we've detected about your code that is security concern issue. And Semgrep already delivers a really good platform, both for finding things out of the box, as well as Juicy said earlier, for really customizing to both security and non-security best practices you want to enforce in your code, things that you want to make sure people are using the right library or doing things the right way in the most secure manner possible. So Semgrep creates this platform creates these rules, also allows you to create your own rules to find things like that. Um, we've talked a little bit about true positives and false positives, and we'll get more into that in a minute. But we want to make sure that we only spend human time, both AppSec and developer human time, paying attention to things that, based on the context, the rule matched, so the rule's probably correct, so the finding is probably correct, but that where the context suggests that this is worth your time to pay attention to because it's exploitable, because it's really important, because the kind of thing that will happen if you don't pay attention to this is really bad. That's the kind of thing that we want to spend your precious time on. So within that, security researchers, as you can see here, agree with the AI auto triage 96% of the time. And
I
we
think you got to go one slide forward.
yeah, so I'm just reading the second section on the
Oh,
right
I see.
here. You're right, it's called out later. We then go down to prioritizing those findings. So sure, there are some that are false positives, and we can take those away from you. We can focus on the true positives, the things that really do need attention. But you still have limited hours in the day. You still have only so many developers and so much time, and they need to ship products, not just fix issues. And so we want to really AI and specifically SimGraph Assistant really focus on using AI to prioritize what are the most important things to pay attention to right now. What really needs to happen now, and then if we left it at that, that'd be kind of a burden. It'd be more of a punishment than a gift to deliver this to you. It's just a to-do list that's generating ever more work. But we don't leave it there. We actually generate fixes for you. So we explain to you in the context what what does your developer need to know in order to fix this issue? Like, why is this an issue? Why is it important? Why even pay attention to this? And then also, here is the fix. Here's the diff. You can just apply it directly. You don't need to think too hard. You can understand, you can learn from it, or you can just simply put it into your code.
If I could say one thing for
Yeah.
in regards to the fixes, I think, um, as Eric mentioned, this is all just kind of like a funnel, right? And so I think that um, the most commodified thing in AI SaaS right now is definitely just generating fixes, right? But I think something that's important to consider is that, hey, if you're just generating fixes at scale for what is probably like 70% non-exploitable findings or like a bunch of false positives, that's not actually helpful. The only thing you're really doing is like you're scaling up the noise, right? And I think at SemGrep, our approach is to, Eric will keep talking about this and I talked about it, but we're really focusing on using AI to understand the context of your environment to eliminate the noise. And then out of that subset of findings that we know are exploitable, let's generate fixes. And our kind of mantra around generating fixes is like, hey, we're generating the code diff, but we're also generating instructions and context in English language or in natural language for the developer. And this is all under the perspective of like we design all this as if it's for a developer who just finished their undergrad CS degree. They just started working at like a FANG company or something, not any experience with secure design or security. We want to make sure that we give them the explanation that helps them A, upskill a little bit and learn a little bit about that type of vulnerability, and B, feel confident that the diff that we've generated is actually the correct fix. So developers actually feel good about committing the AI generated fix. They're not just getting blasted with a bunch of AI generated fixes and they're like, like some of these are false positives. I don't know if these are correct. It's really, really centered around the developer experience. And what we found is that this actually is a fantastic way to help upskill developers. It's much more effective than doing some bespoke like security training every 3 months where you make them watch like a 2 hour video or do like a bunch of modules. Essentially, developers are having these like micro learning experiences in their PR over time, and it really helps them upskill in a way that actually lasts and in a way that's not super annoying for the individual developer. Um,
That in their PR part is really important because as I have a background in education as well, and people learn much more, retain information much more, for much longer and much more effectively when they learn in the context of something they already care about, rather than some abstract setting where they're just being asked to care.
Exactly.
So
Yeah. So the whole philosophy of SemGrep is that from the developer's perspective, they are never leaving their native workflows. Everything that they need to see, you don't have to provision your developers access to the SemGrep platform like you might have to with other vendors. Everything that happens, everything that's needed for remediation is brought to them in context. And then I think the other thing that, like I said, I think AutoFix is pretty commoditized. So it's like it's difficult as a marketer to explain why is ours different. I think that learning component is the first part, but the second component is, well, we just have the Semgrep Pro engine, right? That's deterministic. And so um, an AI can generate a fix and it may not be correct, but we can validate if it's correct or not by running that code diff back through the Semgrep engine. And this all have the Semgrep engine is very fast, it's very transparent, right? And so this can keep happening and the AI can keep going until it can figure out and generate a code diff that actually does resolve the core issue to where that finding is actually removed.
Okay, so let me switch gears for a second and talk about where do we use LLMs here? Where does AI come in here? One of the questions I get asked sometimes is, are you guys training your own models? Are you fine-tuning your own models? And which models are you using? Why are you using those models? Can we use different models? Can we provide the model, etc.? So let me talk a bit about that, and I'm happy to take questions as well. These are two evaluation frameworks that you can see are two evaluations that we run on open the foundational models. And you can see that from left to right is this list in the middle here. So GPT 4.1 is the red bar, Claude 3.7 Sonnet is the blue bar, etc. And what we find is that we evaluate each and every model each and every time it's released, each and every time it's updated, and just continuously when they're not updated in case they've changed, we evaluate them on a whole rigorous host of different benchmarks internally. And we're actually working towards publishing some of this data externally as well. But you can see the first glimpse of that here. And we evaluate them on the different abilities in different contexts, both in terms of triaging and finding whether something's true positive, whether it's a really important issue, does it detect that well, whether it's a false positive issue, is this something that's going to waste your time or it's not exploitable, and so therefore you don't need to focus on it too much. We also evaluated on code fixes, whether the code that's generated solves the issue, whether it's understandable, whether it fits the code paradigms in the code base. So these are some of the things that our users care about. These are some things that we care about. And you can see that different models have different trade-offs. For one thing, the models that do best on one benchmark don't necessarily do best on another. So we use the best model. We use each model for what it's most useful for. For each problem, we use the best model available, and that changes constantly. We end up having to change which models we use for what on a regular basis as new models get released. And this is why we don't tie ourselves to fine-tuning one model, or we don't tie ourselves to training our own model, because every time you do that, and I've talked to heads of AI at many different companies, uh, unless you actually unless your business model is to provide the foundational model to the world, like Anthropic or OpenAI, et cetera, or Google, if that's not your business model, then it's not useful to compete with them by trying to train your own model, because that's what you're doing is you're competing. If you instead benefit from the constant innovations and then build around the model, build the right questions, build the right interpretations, build the right evaluation sets, et cetera, that's how you move with the models instead of against them. And we are very much on the side at Semgrep of moving along with the models and winning, benefiting every time one model, takes the lead in this race. So that's where we're at with this. Let me jump to the question. One would think that if finding a true positive on the other side is that the other side of the coin. So then why do I have different scores? Am I missing the criteria? Yeah, it's a great question. So this is a different way of, and I had the same reaction to this graph at first, by the way. This is that's correct. That detecting that something is a true positive is another way of saying detecting that it's not a false positive and vice versa. What this is showing is that it's a precision recall trade-off for those that are familiar with binary classifier evaluation sets. But basically, we can prioritize making sure that customers always get true positives in the set of findings that we call true positive, that we call their attention to, at the risk of occasionally letting a false positive in. Or we can prioritize making sure that all of the false positives are out of the backlog and that you never see a false positive at the risk of potentially missing one of the true positives, something that might actually be exploitable. And so no classifier is perfect. No AI model is ever going to be perfect. And models do get better at both of them over time. And so we see that things that we do internally make them move both metrics upward. So these are not zero-sum metrics. You don't see that one bar is always lower when another bar is higher. Sometimes one model is better at both than the other. But the reason for that is because models could just be better than the others. Like, a random coin flip, for example, would be at 50% on both of these metrics. So what we're finding is that some models do better at making sure that we catch all of the true positives. Some models do better at making sure we catch all of the false positives. and some models do better at both. There's no Gemini 2.5 Pro evaluation for true positives. Oh, that's an interesting point. I see 6 bars. Thank you for catching that. That is, I think I might have copied the wrong graph here. That we do have evaluations for them, but I made this. This is the most recent slide that I made that I added to the deck, and so you're right that there's the yellow. That's the left one stops at yellow, and the right one on the right has the light purple. So I think I copied the wrong graph and didn't include it here. But I appreciate the call.
You're interested, we're happy to send this information. And like Eric said, we're in the process of like thinking about building out like a kind of like an arena where people can publicly see where we'll publicly publish our benchmark results. But I think just to reiterate what Eric said, yeah, it's not a zero-sum game, and essentially like from a product perspective, the way to think about it is our product like these features are only useful if customers can really trust that when we say you don't have to worry about this thing, like we mean it and we're accurate and we're confident, right? And so like Eric said, there's a trade-off there of like occasionally letting a false positive slip. Our priority is that when we tell you that something is a false positive, we're right almost 100% of the time. And so because of that, you're going to have a very distinct like prompt chain and essentially like like a prompting and retrieval mechanism that's like over optimized for correctness. If it was a zero-sum game, it would be a lot less useful because it might be more accurate in the aggregate, but you'd have, like if when we tell you something's a false positive, if we're only right like 70% of the time, that is profoundly less useful than our current rate, which is when we tell you something is safe to ignore, we're right over 95% of the time.
Yeah, so let me since Shushi mentioned that statistic, let me go to that slide next. And let me take the question first because I want to make sure the questions are contextual with the slides that we're talking about. Only a subset of the benchmark will be available for the public. I'm not sure which comment you're responding to, but we currently, I don't think I'm not aware that we've published, other than in this talk, we've published any of these benchmarks, but we're aiming to publish our benchmarks and the results soon. I don't have a timeline on that today, but that's one of the things we're working on. And part of the purpose is to help the world and the ecosystem have a good idea of how these models help with security, which ones are doing better, and to give them an incentive to compete on that metric, et cetera. And so we'll make as much public as we can. Uh, there's nothing particularly secret about these benchmarks, which is why I'm sharing them with you. We just haven't taken the time to stop and publish them rather than we have taken the time to make sure that they are improving our products and that the products are constantly getting better. And we've been prioritizing that, but we would like to take a second to publish the research so that so that the ecosystem can benefit as well. And please keep the questions coming if you have any. You can see here, as she was mentioning a second ago, when we tell a user that something is a false positive, that is to say, not exploitable, not worth their time to prioritize, they agree with us 95% of the time. And security researchers who have a deeper understanding of the context of those findings agree with us 96% of the time. And that is not a quick, like we asked 20 people, and one of them said they disagree. This is over a thousand customers, over 1 million findings, and over 90 enterprises that this data is collected. So we have a very high bar for when we say something's a false positive that people will agree with us, because again, trust is built slowly and lost quickly, and we need to make sure that people can feel safe and sleep well at night knowing that when we say something can be ignored, that we're probably right. And that when conversely, when there's things left in the findings list after that happens, that it's worth their time to look at. The way to think about, oh, okay, she's answering your questions. So let me go down to why this approach. We have the Semgrep Pro engine, which you may be familiar with, but is the world-class engine, I understand, to find issues with high precision, high confidence, customizably, relatively easy to build rules for, to make your own, to customize your own, to turn on or off rules, to customize the findings, to add exceptions, add rule explanations, etc. It's a very customizable solution, but that comes out of the box with great coverage, so you don't have to customize it if you don't want to. It starts out really good. Why use that in combination with LLMs? I think we have an idea of what LLMs are good at. We have an idea of what Semgrep is good at. So the Pro Engine is good at. Why are we combining these two things? So to start with, why use LLMs? LLMs, as Chuchi was mentioning earlier, understand the intent and the context of the code. It can read the code for some definition of read. It can understand for some definition of AI understanding what the code is doing. And it uses all of those, not just structural, but contextual. It can look at comments. It can look at the function and variable names. It can look at the things that the code is doing and really understand and use that context to decide, is this really important or not? What's the risk here? In a way that a human could do, but that a rule system would have a very hard time doing. It's not just that it understands natural language, but it also is customizable by the administrator or the manager of that system using natural language. So you can use natural language to give it directives and to change its course in a way that's much more sweeping and broad and effective across the board than tweaking things one knob at a time. Uh, so those are some of the advantages. Is basically it's what it sounds like. When you say a large language model, what does it sound like? The advantages is it understands language. It understands natural human language. It also understands code. So it also generates code much more effectively than a rule system would because it can output code in any language that you might want it to output code in for any language that's got public data to train on. Why the semantic engine then? If LLMs can do all of this, why do we need an engine? Well, what LLMs and natural language systems are not great at are the following. They're not deterministic, so you might run it one day and get a different answer than the previous. They're not so consistent, and that's not great for compliance or auditable professions like security. It will let you attribute why did we find this? Where did it come from? What's the rule? What's the provenance of this finding in a way that's you can recognize and be familiar with and make sense to you and not some deep model weights that you're gonna have to interpret. The user has control. You can turn the rules on and off at will, and you can figure out which rules are firing more often, less often, which ones have more signal and more noise, and customize them as you see fit. Every finding, every issue has a vulnerability category and an explanation attached to it. And this is something you can ask an LLM why it did something, and it can give you language that sounds reasonable, but it's not attached to this structure like here are the types of vulnerabilities I'm looking for, and here are the things that I found in each category. It doesn't have that kind of auditable structure to it. Perhaps most importantly, the semantic engine is efficient and costs a lot less than the large language model. Executing a large language model a single time is affordable. You ask ChatGPT a single question, you're not going to be crying about your next credit card bill. But if you ask it millions of questions, you will. The large language models are efficient for small sets of use cases, and with a high enough value, can be efficient at large scale, but they're not efficient enough. They're not cost effective enough to run over every single line of your code with every single rule that you would want to execute on. It's just they're not there. They're also faster. Even if cost wasn't an issue, you can scan the world's biggest code bases using Semgrep's Pro engine in reasonable amounts of time, in hours, not days, or even some, in many cases, minutes, not hours. And you can't do that with large language models. You don't have the bandwidth for one thing, and they don't, and the cost to serve is just too high for the model providers. So it's faster, it's more reliable, it's more consistent, but it lacks the context. Large language models bring the context and the understanding. We talked about this. What are the responses? So you can see this quote from the product security at DigitalOcean. And he says that the analysis that Semgrep Assistant gave is comparable to the analysis I would expect of my security engineers, not the analysis he gets, but the analysis he would expect of the security engineers, subject matter experts, if they were manually analyzing the code base with an understanding of their company's specific nuances, which a new security engineer on the team won't have. But a very experienced, has been here forever, has seen the skeletons in the closet, has seen where the bodies are buried. That person will have enough context to understand this stuff. That's the kind of outcome that our customers are recognizing in Semgrep Assistant. What does a false positive look like? We talked about it a bit, but I'll go over a little more detail into what we're talking about here. Let me skip ahead to this slide for a second. So take this example. You write a rule, or you have a rule turned on that says make sure that when you're taking some input from a user and then using it in a certain database call or a function call, that the data is validated first to make sure that it's not malicious. And you might have a variety of different ways inside of your company that you check for things. You might have three different utility functions. Maybe one of them was written by a company that your company acquired, and so there's different, or two different teams built their own and not knowing about the others. There's a million different reasons we'd have multiple ways of doing things. And so you could use Semgrep to enforce that everybody does things the right way. But in the meantime, while the backfill's still going on, you can also use Semgrep to assistant to say, hey, look for validators. I don't want to tell you that it's called check safe. I don't want to tell you that it's called validate proxy request. Just look for validators. And if you see that, don't worry about it. If the code was checked before it was executed on, you're fine. So that's an example of what you can do with the memory. You can see now what that memory looks like here. We have some sort of validation. And if there are functions named validate, sanitize, you honestly don't have to give us these examples. It'll figure it out. But if you really want to be clear and robust, you can say anything with validate, validate, sanitize, clean. If it says that, it's probably checked. And apply that to all of the code in this project, JackSite, for example. Or if you have you can apply it to all SQL Alchemy Flask rules findings. You can apply it to all findings. You can apply it just to the findings of certain categories, etc. And it will go back through and say, I'm going to knock out all 43 in this example findings that are in your backlog that applies to this, or only the ones that where the of all of those findings, only the ones where the validation is present. It's going to go check every single one out, analyze the code, and figure out which ones we can remove for you. So that's what an auto triage memory looks like. Here's some more examples. The boxes in red are some examples of memories. This is a new memories page we just launched recently. You can see in the impact column underlined here that each finding tells you how many findings, each memory tells you how many findings it will affect, meaning you can wipe these things out of your backlog, or in some cases, you will start to have these as findings when you wouldn't before. Auto triage memories can both tell you, hey, emphasize, like make sure to call my attention to these things if this happens, and don't bother me with these things if this happens. So you can go in both directions. And you can scope them, as I said, to all rules or to just some rules, to all projects or to just some projects. Projects essentially means repos. And it will be able to tell you these are how many things are in scope. For example, 3,125 findings are in scope for this set of rule and projects, and 580 of them will be changed. The outcome, the triage recommendation will be changed, as an example. Oh, and one thing I want to emphasize here is we have both suggested memories and active memories. So you don't even have to write these memories yourself. One of the great things about this new memory system that wasn't true 2 months ago is you can now just trust that Semgrep Assistant will learn from you. So you don't have to consciously, as you saw on that other slide, we are creating a memory. It says create memory at the top here. You don't have to create memories anymore. You could, or you could just tell us why this one particular example is not worth your time. And Semgrep Assistant will generalize to the entire code base. It will just learn from you. Here's an example of our recommended uh, triage recommendations, so our recommended change to your backlog when you apply memories. So for example, this particular memory that was created here will change from 18, will move the needle from a system is able to identify 18 things as likely false positives. You can probably ignore these to 588. So it adds 570 new likely false positives, and it reduces the number of things you need to pay attention to. Your likely true positives from 911 down to only 341. So this wipes out a whole lot of your backlog, saves you a lot of time, and makes the rest of your day look a lot more tractable, or the rest of your team's week. And this is an example of the kind of thing that we see a lot of love from customers from. There's a whole lot of one of the best parts of my day of my job rather is that I pretty much every day get Slack messages that are like, hey, you really need to understand how much these customers love Semgrep Assistant. It wiped out their backlog, it eliminated false positives. They really are just loving this product, and this is a good example of it. So Luke from Copper said, so far we've only added a few memories, but they've been so quick to set up. And this is actually before some of the recent features, so they're even quicker to set up now. But he said they seem to catch all of the false positives. We've had at least 3 customers, like they go off the top of my head, tell us, I ran the backlog and then I ran SemGrep Assistant over it with memories, and I looked at every single finding in this repo or in this large set of findings that I wanted to evaluate, and every single one of them is a true positive, needs to be fixed. None of them are a waste of my time anymore. We've had a number of customers tell us that in their evaluations. So another quote, the ability to have SemGrep Assistant remember what I told it and automatically triage for me in the future is game changing. That's what I was emphasizing earlier. This isn't like, hey, create something, set something up, just define a new rule. These are not rules. This is just tell us why we got it wrong and we won't get it wrong anymore. That's how it works. So how does Assistant do this? How does triage work? So you don't have to understand the whole graph, but basically we take a vulnerability, we take a bunch of context and understand things about it. We triage it, which means we tell you whether we think it's true positive, false positive, whether it's worth your time. We generate guidance for it. Here's what you can do about it. We generate a code fix. Here's the actual code you can adopt if you want to. So this is a high level understanding. There's a lot more details than are described here, but this is a high level understanding of the flow of Semgrep Assistant. And what is the impact of this? Why? Why do we build this? Why do you care? We want to make sure that when when AppSec is talking to their developers, they can tell their developers, we won't waste your time. You can trust that if I'm at your desk, metaphorically, talking to you, it's because there's something that you care about. You're going to want to hear this. And we want to make sure that Semgrep is doing the same thing for your team. We won't tell you to fix something unless we can tell you what needs to be changed. Here's a step-by-step guidance on what you need to do about this, not just here's a problem, go figure it out. We will only ask you to fix things that are critical. If it's low priority, if it's in a test file that nobody can actually reach in production, we're not going to waste your time. It's only for things that really need to be fixed. We're going to prioritize not just the important things, but the things that will be easier to fix first. So we're going to make sure, hey, if there's something that we can one-click fix, we're going to give you the one-click fix. And once you're done with all of those things, then if there's something that's really, really important to fix and the fix is just too complex or it's going to be out of bounds, it's not a code-related fix, you're going to have to go to some external system and click some buttons or something, we'll let you know that at the end, but we're going to focus your time on things that are really easy to fix first. And finally, we're not asking you to leave your coding environment. We're not going to ask you to go do research, read an OWASP paper. We're not going to go ask you to figure out what CSRF stands for and what it means. Like, what is that? What do we have to do about that again? Like, what is it, cookies? Or like, what do I have to do there? We're not going to make you research these things. We're going to give you the fix to just apply if you want to. But if you, as Tushi mentioned, to teach a man to fish or a woman to fish, we're going to teach you in the context of you're standing at the lake already. You already have the fishing line. You just don't know what to do with it. We're going to teach you to fish in the context of your code. You're still in the IDE. You're still in the coding environment, the code review environment. We're going to teach you this particular issue is fixed with this solution, and here's why, and here what was wrong with it. You don't need to understand the general pattern or some research about what somebody got exploited doing 20 years ago. This is what's happening in your code right now. And we're ready to take your questions. Here are some resources, and we'd love to hear any more questions that you have. We appreciate the questions we've gotten so far.
I see a couple questions in the Q&A, so I think you kind of went over this briefly, but this question is just what is your approach or thoughts on fine-tuning if you're using these foundational models? It doesn't seem like you'd be able to do that.
Yeah, great question. Sorry that I missed that. I must not be seeing all the questions, but let me go back to this slide. So, what is my take on fine tuning? I think so. I come from a long history of machine learning and AI, and I think that training your models, I think the most important thing in modeling generally in any context, both pre and post LLMs, is asking the right question and making sure that the business problem that your customer wants you to solve, the high level, like, should I pay attention to this finding or generate me a code fix that's actually going to make sense in the context of the code base that I'm working in, not just some generic snippet from Stack Overflow. Those are examples of business problems. Mapping that to the right question to the model and framing that well. I think that good modelers answer that question first, is like, what can a model answer and how do I turn this business problem into a modeling problem? And then there's all kinds of questions about data quality and evaluating the output correctly and so forth. That's like kind of what modeling and training is. I think fine tuning is a way of doing that, especially when somebody else already has a model that's better than what you're going to train on your own or has more data to train on than you do, but you want to make sure that it applies well to your domain. And I think a lot of security companies talk about fine tuning. Most companies, security and non-security, most companies that talk about fine tuning models or training models, what they mean is we technically trained a model at some point in the past. We put it on the shelf and it has not touched production code in years, but we did do it, so we can say we did it. And actually, we're just using off-the-shelf models. That's what they typically mean. the other thing that people do most commonly today is prompt engineering, which means figuring out how to tweak the questions you're asking to get better answers. What I want to say is it does make sense to fine-tune models sometimes, but only in the case where the model that you're going to start with and then fine-tune on top of is static and is not good enough, and you're going to pin to it. If the models are getting better faster than you can fine-tune, what that's going to mean is that the model that you end up with at the end of that fine-tuning process is inferior to the model you would have otherwise used without that effort. And I think our customers would rather have us focus on making this system and the platform and the data available a lot better. To go back even further, you can see this slide that Chichi went over. We Most of the performance of language systems or large language model based systems today comes from giving it the right context and asking it the right question, not from retraining the weights of the neural networks in the model. We could do that. We have done that. We have tried fine tuning things, but it's just not worth the effort. It's not the right way. It's not worth the effort. It's the wrong way to say it. It doesn't have good outcomes. The better outcome comes from giving it better data and framing the question better to the platform. That's what gets us better results, not changing the weights of the model.
Thank you. Yeah, and I would say like I guess the inverse of that kind of question is if you were talking to a vendor and they did fine tune, you should really try to get to the bottom of like, hey, are you guys using the foundational models? And if the answer is actually no, then like, you should be really curious about what the performance looks like with whatever open model that they had previously used that they had fine tuned. Because
Yeah,
generally, or go
sorry.
ahead. I was saying
Yeah,
generally only really effective with like hyper specific, hyper niche use cases.
yeah, I would like, for example, in this slide, I would love to hear from a vendor. Here's how we evaluate whether you're doing well for you or not. 96%, 95, 96% of the time you tell us that. I think it's actually 96. The slide says 95, but it's actually 96 plus percent, I think, internally. But anyway, 96 plus percent of the time when we say something's can be ignored, customers agree with us. It's a low priority finding, it's a false positive. And here's the evaluation. Here's how each of the models contributed, the foundational models contributed to that. But as you can see, none of these numbers are over 90%. So like the things we do on top of the models make them work better. This is just the model's contribution. Like we actually are performing better than these models do with the models. So it's not like we're not adding to them. It's not like we're using them out of the box and just giving them to you. Like Semgrep wasn't here, the models would not be achieving the results that they're achieving. Um, so I would love if I was evaluating a vendor, Semgrep or anybody else, I would say like, what specific question does your model answer better than the foundational models? And can you show me that data? I would love to see a graph. I would love to see a chart. I would love to see like for 14 versus 13, like what was the comparison and how much better did you do and which models did you compare against and how much worse did they do? Um, and the my prediction is that other companies are finding similar things to what we're finding, which is when you use the other model, when the foundational models, you can get really bad performance if you don't ask the right questions, if you don't give it the right data, if you don't have the right context. And one of the things that SemGrep has that other companies typically don't, most companies don't, is the SemGrep Pro engine that can really figure out what's going on in the code beyond the text. So the LLM is really good at reading the variables, the class name, the comments, etc. But it's not as good at understanding the structure of the code from a syntactic perspective and code flow perspective. And if it is able to figure that out, it takes a lot of tokens and a lot of compute. And that's what SemGraph can do very quickly and effectively across your entire code base.
Yeah, like I think being able to programmatically like trace the data flow, right, is not something that a large language model can do. It's only something that maybe you could simulate, but there's no programmatic way for the LLM to do that. But luckily with SemGrep, you kind of get the best of both worlds. Okay, someone asked, how do we get access to SemGrep Assistant? SemGrep Assistant is not an add-on product. So if you were to just trial SemGrep or try the free version of SemGrep or use SemGrep, you would just get access to SemGrep Assistant. I think the key detail is in settings. I believe it is, I believe it's opt out actually at this point, but if you're an existing customer, there is a chance that it is opt in for you just because obviously when we first started building all this stuff out, we didn't make it opt out.
Yeah, so if you have SemGrep Pro, go to the UI, semgrep.dev, log in, and then click the settings, and there's a section called Assistant. You can turn it on there if it's not on.
And if you're more interested in the benchmarking stuff. Like Eric said, we're working on having a way to kind of just like publish those results. I think, we don't want to just publish a blog post one time and have that be out of date in months. So we're really looking for a way to like maintain just like a consistent stream of like what we're doing to this page so people can reference it. But if you want to read this case study we did with Anthropic, I think it outlines, it goes into a little bit more depth as to like what our evals are like. And like I said, we're model agnostic, right? So we're not like tied to using Claude 3.7 in production. And I believe that actually Eric was just talking is like, I think the new version of GPT actually outperformed it in some areas. But I think it's a good case study to read to just show the types of incremental improvements that can come from these model updates. So that's more in favor of not fine tuning, right? Like this new version of Claude dropped, and we saw, I think, like a 20% improvement in our ability to detect true positives or something like that. And so the cool thing is that our customers, they get really excited when these new versions of models come out because they're excited to see how that translates to outcomes for themselves. And like I said, our focus at Semgrep is just on making every model better by giving it the right context, helping any AI model, whether it's one that's released today or one that's much better, released in 6 months, regardless, just helping any model make better security decisions more reliably.
And we actually work with the providers themselves to help give feedback on how they're doing at the base level as well, to help them get better at their foundational models. But the more important thing is uh, whether the product, the SemGrep or whatever scanner you use, works well is not dependent on not just dependent on which model they're using. It's also what they're doing with the model. That's the vast majority of the outcome is what they're doing with the model, and that's what's going to differ a lot.
Then I have one more question here. I think Eric answered is pretty straightforward, but it's just yeah, like compliance wise, if there is a customer, I'm summarizing here, but if there is a customer that is tied down due to like a data processing agreement with OpenAI or Anthropic, can they kind of override our selection process?
Yes, the short answer is yes. You can, so first of all, by default, SemGrep assistant customers, by default, SemGrep code customers are assistant customers. And by default, assistant customers, you get whatever model we choose for whichever flow we choose it, based on the benchmarks I mentioned. Different flows and different use cases have different best models. But you can, and then we have, you can provide your own model API keys. You can tell us, hey, I want to use this model, and here's my API key. Can you use mine instead? And we can do things that way. You can also, if for some reason you can't use models, you can turn that part off. You can turn assistant off. But to get the best experience, you can either use what we pin to, or you can use what we are, the cutting edge, whatever's most recently effective, or you can pin to a version that you really think you need to use with your own API keys. So they're both available options.
Yeah, and then what's great about our philosophy, right, is that you use your own API keys, and you're still going to get all of the improvements that just come because the value and the differentiation we bring is, again, like Eric said, the context we give to the AI, the scaffolding we've built around it, the retrieval systems and the prompt chains that we've built around all of these task-specific things in the AppSec world, like remediation, or false positive identification, or like file classification. So, we just help any AI do those things better and more reliably. But I think we're actually over a little bit time. So if there's any other questions, feel free to email them to us. But yeah, thank you so much for your time. And yeah, we'll try to make these slides available and the recording available as well, so you guys can reference any of the information that we brought up.
And we appreciate you all being here with us.
Yep, thanks so much.